Okay, good evening, everyone, and thank you so much for joining us for this live streamed presentation. Tonight, we're learning all about bats with Dr. Debbie Buecher, and I am Beth Courtwright, the Adventure Programs Manager at Pajarito Environmental Education Center, or PEEC. We're located in Los Alamos, New Mexico, and I'll be the moderator for tonight's talk. The Los Alamos Nature Center is currently closed, but we still have lots of ways that you can interact and connect with nature. Check on the PEEC website, it's peaknature.org, for more live stream presentations like this one. And we also have on your own activities like our Trails Passport and even some small group programs going on in person right now. PEEC is able to offer programming like this because of all of our wonderful members and donors and volunteers and staff. So I'd like to send out a special thank you to all of you for your generous support. Debbie Buecher is a bat biologist who works extensively in New Mexico and Arizona. She has studied bats for 34 years and owns a consulting firm specializing in bat research. For her clients, she conducts mist netting to determine species diversity, and she also enters caves and mines to evaluate them for bat use. She performs acoustic surveys to monitor species presence and activity levels across landscapes. And I know we're all looking forward to hearing about Debbie's research and the lives of bats. So without further ado, I will turn it over to Debbie and monitor for any questions or comments coming in the chat. So let's see. Debbie, you can go ahead and unmute and yeah.
All right. Welcome. I'm glad everyone could make it to the Halloween bat talk. It's interesting because October, I often get a lot of requests for talks, and that makes sense because bats are sort of prominent in people's minds because of Halloween. But unfortunately, it often brings bat myths more to the forefront. And tonight I would really like to focus primarily on bat facts. So not all cultures perceive bats as a negative. In the 16th century China, and even today, the Chinese had a positive perception for bats. Fu is good fortune. Bianfu is a term for bat. And when you look at some of these, these are decorative bats, 5 decorative bats used in textiles, used in pottery, and they are the 5 blessings of life: long life, good health, wealth, love of virtue, and a peaceful death. So this is still the culture, Eastern culture, about bats. Even in the New World, the Mayan culture that extended from 2000 BCE to the 16th century, they have a calendar, just like we have a calendar, with horoscope creatures or caricatures. And this is a bat. Zats is bat, and Kamazats was the bat god in the Mayan culture. And they divide their year a little differently than we do. We do it 30 days. They do 19 periods. And the time of September 24th to October 13th is the bat character. And when you look at, there we go, when you look at this character in more detail, what you're seeing is a nose leaf. This is a flap of skin on a certain family of bat, which is down here. That's the nose leaf and the large ears. And these phylostomid bats, the nose leaf bats, are very common in the Mayan area. And so they had a positive perception of bats. Even locally in New Mexico, in southern New Mexico, from 150 AD to 1400 AD, the Mimbres culture was prominent, and they made beautiful pottery, and they used animals, and so they used turtles, quail, deer, and they also decorated their pottery with beautiful bat paintings. But if you come a little more recently, today's perception of bats in the US tends to be a little bit more Dracula and horror films and witches and bats, but don't give up too much, because we do have Batman. So we don't have a totally negative perception of bats. But I'm going to now talk about bat facts, and we're going to start out worldwide, and then I'm going to focus more, bring it into New Mexico. Worldwide, there are 1,424 different kinds of bats, bat species, distributed across 18 different bat families. Now, it's interesting because last year there were only 1,411 bat species. They are still finding bats that have never been described, and they tend to be in more remote areas like Southeast Asia, in through the Congo, and so not all bat species have yet been described. When we look at bat diversity, bats are second in diversity to rodents. There's so many bat species that they're just under rodents for diversity. In the US, we have 45 different kinds of bats, different species. And here in New Mexico, there are 29 bat species. And the faces all along these 6 bats that are shown on the screen are all bats that you would find in New Mexico. So not even looking at 29 species, just looking at 6, you can see the tremendous different colors, different size ears, different shapes of noses, long fur, short fur. And bats are found in New Mexico and worldwide across very diverse habitats. So in Arizona, there are bats that are just as happy in the Chihuahuan Desert. And then you get up into the grasslands and pinon juniper, you might find different species through those gradients of different temperatures and relative humidity. And then you'll find bats up on the mixed conifer in your mountain ranges. And bats are found on all continents except Antarctica. So here's a map of North America. And this sort of brings home the fact that in Arizona and New Mexico, we have the richest bat diversity, with the oranges and red being the most bats, and then the blues, light blues, less number of bats. But this makes sense because when you look at diversity of plants and animals, the greatest diversity is around the equator. And as you leave the equator, you start getting fewer and fewer species until you get up into the Arctic. But right here where we're sitting in Arizona and New Mexico, it is really rich in diversity, bat diversity. So people will ask me, well, how long have bats been around? Well, bat bones are very, very fine, and they break easily, and bats get articulated very easily. So it has to be a very special sediment on which the bat lands, and then gets covered almost immediately, so waves don't break the bones apart. And these two fossils from Wyoming and Germany are 52.5 million years old, fossilized in shales. And these are fully looking modern bats. They have the long fingers of the wings. They have the typical tail. You can actually look at the ear bones and tell that they were echolocating 52 million years ago, and even some of the stomach contents can be seen if a bat is perfectly fossilized. So when we try and think of the ancestors to bats, we don't have any fossil material because it is so hard to find. But they hypothesize that they were nocturnal because bats have always been nocturnal. They were nocturnal small mammals, sort of shrew-like, scampering around the trees, chasing insects. And then through time, they evolved probably a gliding membrane and then wings that became true flight. And bats are the only mammals that can fly for miles and for hours. Now people say, so let's talk about what makes bats unique. So like I said, it's the only mammal that has self-powered flight. Bats will make long migrations. They'll forage throughout the night. They'll fly over mountain ranges, and it makes them very difficult to study, because if you put a transmitter on a bat, it can be over the mountain range so fast that you can't even find it by following roads. But it has made them extremely successful by filling in the nocturnal niches of leaving the landscape and chasing down aerial insects. So bats probably evolved because there was all that food out there that nobody was eating because it was flying around. So bats have become very successful and have moved into a tremendous number of niches. You've probably heard of flying squirrels and flying lemurs, but these are actually gliding animals. They have to climb up something, a tree, a vine, and they leap off and spread their gliding membrane. They are losing elevation as they go. They can steer, but they can't fly for miles and for hours. They're leapfrogging. They're climbing up something, gliding, climbing up something and gliding. It's kind of a misnomer that they're flying animals. When we look in more detail at bats' wings, it's really surprising because it's so similar to our arms and hands. Bats' wing is actually a highly modified hand. Bats with the purple, when you can look at the purple bone, the humerus, they have shoulders and elbows just like we do. They have a radius ulna that goes from the elbow out to the wrist. The wrist is a little simpler in bats, but when you look at the bat's fingers, they're all there. There's the thumb, finger 1, finger 2, finger 3, 4, and here's the bat's pinky. And supporting the wing, the fingers support 2 layers of skin that are highly vascularized. There are a lot of blood vessels, there's a lot of muscle, and flight is very energetically expensive, so that's why you have so many blood vessels. And then the membrane goes from the bat's 5th finger down to the ankle. So when a bat is flying, it is literally flying with its hands. These fingers lend really good support to these membranes, because if you didn't have those bones, that skin would just flap. But these are a lot like the slats in a sail of a sailboat. They lend support, and bats can change direction in flight by flexing their fingers, changing the direction of flight by changing the shape of their wing. Here again is another cross section of a bat, but it reviews the elbow, forearm, the finger bones. But in addition to the 2 wings, bats also have the tail membrane, and it's called a uropatagium. For many bats, the tail is totally enclosed in this membrane. 2 layers again of skin, blood vessels, muscles. Some bats have less of the tail exposed, so the tail membrane may go up to here and then over to here, but even then they can flex that membrane to help catch insects. So the tail membrane is important to helping bats steer. Besides using their wings to steer, they can change the angle of their legs, and the tail membrane acts like a rudder. Scientists used to think that bats would be flying and catch every insect in their mouth, but that would require very accurate flight, and your dinner's trying to get away. But with high-speed photography, where they could see every wing beat, they were able to see that as a bat approached an insect, it could reach out with its hand, which is essentially its wing, or it can scoop it up like a catcher's mitt with this tail membrane. And so a bat only needs to get approximately body shape away from an insect to essentially embrace it and then put it in its mouth. Another important value to the tail membrane is for females, because when females go to give birth, they turn around and hang by the ceiling, say, of a cave, and curl that tail membrane. So as the baby is born, it drops into that catcher's mitt. Baby bats have very large hind feet, a lot like puppies have to grow into their feet. Baby bats grow into their feet, and they're called pups. Baby bats are called pups. So the baby then climbs up on mom, and then the mom can embrace the pup with its wing and close it in the adult wing. When we talk about bat reproduction, most bats have one pup a year. There are some species that will have twins, but if you generally say, well, you know, a lot of mammals have litters, bats do not have litters. They have one pup a year. The center picture shows a baby bat, newborn baby bat. Their eyes are closed, their ears are curled, and they're totally naked. They're completely dependent upon mom's rich milk. They're very helpless when they're first born. Here's a free-tailed an adult Brazilian free-tailed bat. They're also called Mexican free-tailed bats, so you might have heard them call that. But this is a female, and here is her pup suckling on the mom. And you can see here that this pup, yes, it's still naked, but its eyes are open and its ears are alert. So you'll see sort of across a nursery, different stages. You might find some babies that already have peach fuzz or a little bit of fur on them. And as they age, a week, 1 week, 2 weeks, they get more and more of a fur coat. By the time they're flying at 4 to 6 weeks, they're sometimes difficult to tell the adult from the child, the adult from the pup, except for the pelage. The fur is a little more gray colored. So the picture to the right is a Western Canyon bat. It's the smallest bat in North America. And this female was caught a little later in the evening, and she probably nursed her pup right before she left to feed. And then she's been foraging and she's been producing milk. This is milk tissue. And you can tell from that she's actively nursing a pup. So after she's foraged for a while, she'll probably go back, nurse her pup again, and then she may go out in the early morning to get another snack before she goes back to roost for the day. Well, one of the myths that I still hear, and I've had adults ask me, bats are blind, right? Well, if bats have eyes, just like we do, and bats can see in light, just like we can. But bats are nocturnal, which means they're active at night. They're in a cave, which is totally dark. You can't even see, if we go into a cave, we can't even see our hands in front of our face. But we're pretty clever. We get a flashlight out. We can walk around and see a big boulder in front of us or see the wall. And what's actually happening is light is coming out of the flashlight and going out and is reflected off what's in front of us back to our eyes and our brain. And our eyes and our brain take that information and create this three-dimensional picture in front of us. Because our eyes are offset 5 inches or something, light is reflecting back just differentially enough so that the brain can create that three-dimensional picture. Well, bats don't fly with little flashlights, and so they use echolocation. So a bat generates its echolocation in its throat, just like I'm doing with talking to you and with using my larynx, and they chirp, and that goes out in waves, hits something in front of it, and is reflected back as an echo to the bat's ears. Bats generate high frequency sound, which they project and then interpret the echoes. And bats can hear their world, and they can hear everything but color with reflected sound. let's touch on sound a little bit. This isn't a physics lecture, but sound, understanding sound is important if you're going to talk about echolocation. Light is an electromagnetic radiation, so it doesn't lose energy as it travels. So that's why we can see galaxies millions of light years away. Sound, on the other hand, is a pressure wave. So it goes out in waves and it's pushing the air ahead of it. And so pressure waves pushing air are easily attenuated or degraded. So it takes, you're losing the energy of the sound wave as it's moving out. Sound travels about 1,100 feet per second, and that's about 1 foot per thousandth, or millisecond. Now, bats use high frequency sound. Well, the higher the frequency sound, the more waves of sound. So the more you're pushing air in front of you, so it doesn't seem to make sense. Sound is measured in waves per second or cycles per second. But if you think about it, what a bat is trying to detect, I mean, it wants to miss the wall, but what is actually trying to detect with echolocation is their dinner. And if I am talking to you at about 5,000 cycles per second, and I want to find a moth with those echoes that's about 10 millimeters, I will starve to death. Bats are trying to detect their prey using the sound. So they need lots of waves close together to be able to detect a small insect. Now, what we say is that bats are echolocating above the sounds level that we can hear. Humans can hear up to about 20,000 cycles or 20,000 waves per second. And bats typically start echolocating above that and go up to 100,000 cycles per second. Now, a lot of bat calls are really loud, because if they're at a wavelength that's attenuating, if they make it really loud, it will help. And big browns are echolocating at about 110 decibels, which is like standing next to a jackhammer. So we're kind of fortunate that we aren't hearing bats as they're echolocating. What this means to the bat, since they haven't taken a physics course, is that if they echolocate at 100 kilohertz or 100,000 cycles per second, they will be able to detect 1.5 millimeter sized prey item, like a gnat. If they echolocate at 50 kilohertz, the waves will be able to detect a 3 millimeter fly-sized prey item. 30 kilohertz, you'll be able to detect a 7.5 millimeter beetle. Big brown bats tend to echolocate almost exactly at 30 kilohertz, and they're called a beetle specialist. So their prey items are about that size. And then there are bats that are echolocating at 12 kilohertz because they're eating large moths, grasshoppers, things that are larger. So it is kind of a rule of thumb. The smaller the bat, the smaller the prey item. And as you can look at this chart, the higher the frequency of their echolocation calls for searching for an insect. So a quick picture, the bat shouts out the sound. It goes out as a pulse. The first thing it hits is the moth, and an exact reflection of that moth goes back to the bat's ears. Remember, the ears are offset a little bit, so the message comes back a little differentially, and the bat can tell the size of the moth, and even if it's a moth because it's kind of fuzzy, or if it's shiny and it's a beetle. The rest of the sound goes out in a continuing pulse, and a reflection of the tree comes back to the bat's ears. And the bat can, in its mind and in that picture it's created, say, oh, good, I can catch the moth and turn before I hit the tree. So we're going to put these bat skills together. This is a video created by Aaron Corcoran, who did his doctorate in the Chiricahua Mountains of southeastern Arizona. So when we're outside and we're watching bats, they're flying so fast and dipping and gliding and doing this acrobatic flight, and we can't really see what's going on. They're echolocating above what we can hear, so we can't really hear them foraging for insects. Aaron has taken a video of bats catching moths, because that was what he studied, and he's slowed it way down so we can actually see individual wing beats. And it then has slowed down the echolocation call. Now, when we listen with a bat detector to bats foraging, we hear the chirp, chirp, chirp. And when an echo comes back that sounds a lot like dinner, what the bat does is it starts increasing the number of calls, and it shifts the frequency. All of this is targeting the insect. So when you hear it, it's chirp, 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 zee, chirp, 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 zee, and we call it a feeding buzz. You'll be able to hear this bat doing the search phase and then increasing the frequency. There's a moth, and here's the bat. So instead of catching it right in its mouth, it embraces it and then is able, still flying, to put it in its mouth. It's coming along. This bat catches it entirely in the tail membrane and puts it in his mouth. This bat comes up, catches the moth, goes to process it, but then drops it intentionally. That moth probably tastes bad, and the bat knows it. This bat, everything's going well, but timing is everything. Now, bats are not all 100% successful when hunting. And there it caught it in its armpit, got it in its mouth. They use that tail membrane a lot to help process the insect in flight. Shift out of here to the next one. So one of the things I'd like to point out is the pups of the year have to figure out echolocation. Then they have to figure out flight and not running into things. And then they have to figure out how to chase down their supper when their supper doesn't want to be eaten. And so you have a lot, you probably would see a lot more failed attempts with the young of the year. So it's a learning process, and they have to figure it out to survive. But it's not a free ride to be a bat and be chasing a moth. Through time, bats or moths that were being eaten very successfully by bats evolved what they call an ear, but it's not really an ear. It's a membrane, thin membrane on the side of the insect, some in a certain family of moths. And when that high frequency sound of the bat echolocation hits it, it vibrates. And it vibrates and it tells the moth that it's being targeted. And the moth then does something erratic in flight. Some shoot way up like a U up into the air. Some suddenly spiral down to the ground. And so as the bat is targeting it, boom, 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 all of a sudden the moth's gone. So bats that really depended upon eating moths through time went, well, I can't yell that loud because everybody disappears. Nobody wants to play with me. And so some of the bats started calling quieter, not at 110 decibels, but what we call whispering bats. They're shouting out their call quieter. Well, then the echo is going to be quieter. And so they have bigger ears lined with hairs, so that as those fainter echoes come back to the bat's ears, those hairs vibrate and send the message to the bat's brain. So typically when you see big-eared bats, and they're, all over the world, they are preying on insects or some other prey item that's can detect they're being targeted. So if we look at the resources that limit the distribution of bats, it's not that bad. I mean, it's a lot like the resources that limit our presence. They need adequate food resources, enough food, and of the right kind of food. A moth specialist has to be able to find enough moths, a beetle specialist, enough beetles. Unfortunately, with the droughts that we've had the last few years, the insects are probably not emerging in the large numbers that they were because the rainfall is so erratic. So, and then if you say you're a fruit or nectar bat, they have to be able to find enough plants with flowering when they're flowering. So adequate food resources are critical for maintaining bat populations. Well, if bats are nocturnal in the daytime, they need to go find a nice quiet bedroom. And for bats that live in caves, that works until people go spelunking. And so you like a nice quiet bedroom, you like it the right temperature and humidity, but you don't like strangers marching through your bedroom all night. So they need appropriate roost sites where they are left alone and not disturbed. Another critical resource here in the Southwest, I mean, you go back east and you go over creeks and they're almost always running, and you go over signs that say Pantano River and it's just sand. So available drinking water is critical for bats. This pond is beautiful. It could be totally enclosed by vegetation. Because it's wet, vegetation might have enclosed it. Well, a deer and a fox can walk up and get a drink of water. But bats don't land to get a drink of water. They actually are getting a drink on the wing. They fly low to the water and get a good gulp of water. And then they may circle back around and do it again. So it is important, and resource managers are always focused on this. You need a good flyway. Bats have to be able to get that drink on the wing and not have a pond that's totally enclosed with vegetation. So when we look at day roosts, again, I can't stress enough that bats choose their day roosts for the best temperature and relative humidity. Female bats rearing young need a really warm site that has good high relative humidity because it makes sure that the pups grow really fast. They're born in the summer, they have to figure out all of these things of feeding and getting it fat and able to either migrate or to hibernate. So bats have a very small window and they need to pick a site that's appropriate. Bats also are looking for protection from predators. So you don't want to be hanging too low to the ground and be accessible to predators. So when we look at traditional roosts, those were the roosts that existed on the landscape before we started altering. So natural caves. Here's a natural cave. And what's interesting about caves is that the temperature and humidity may vary throughout the site. It may be cooler in some areas where there's a cold air trap, may be warmer where there's a nice dome, and you might get different bat species roosting in different parts of a cave. Crevices out west here in the mountainous areas, when you go into a canyon, you'll see huge rock walls and they look solid. But if you walk up to them, there are lots of crevices and little holes, and crevice roosting bats will land and scamper in behind that big slab of rock. And to a bat, that's perfect if it can find the right temperature and humidity. Hollow trees, downed trees, some bats are called tree bats, and instead of making large colonies, they roost as solitary bats in the foliage. And New Mexico has 4 different species that do that. and then rock piles. So if we look here at a bat, it's starting to peek out, it's going to go feed. That's a hollow part of a tree. Probably a branch broke off and the tree healed, but there's a little cave-like structure in there that the bat can get away from predators and sleep all day. And what recent research has shown us, which makes sense but was sort of surprising to people, was that debris slopes, scree slopes, there are tons of little caves in there. If you're a bat that has a small colony, 5 to 10 animals, you know, they can fly up and crawl into there and find a nice moist area to roost, and no predator can get to them. When we look at non-traditional roosts, mines, once they're abandoned to a bat's search image, looks a lot like a cave. And so bats will use abandoned mines. Old buildings. I grew up in northern Wisconsin in a 70-year-old house, and we had bats living in the attic. There were little crevices that they had figured out that they could get up in the attic, and they pooped on everything. So they lived in the attic and we lived on the 3 floors below. Bat houses. Bat houses have been put up in certain areas. It's a little harder in the Southwest because our temperatures get so hot that unless you're very careful and maybe insulate a bat house, it won't be inhabited because it's a little too hot for the bats. What's interesting is old bridges have crevices underneath them to help when the concrete expands and contracts. This certain way of constructing a bridge leaves a crevice underneath, and bats will move into those and live in the millions. So at the University of Florida in Gainesville, they had bats living, I believe, in the stadium or in an area that they didn't want the bats to be living. And so they built these bat houses with a lot of little crevices, little places for the bats to live in, and it's become a tourist attraction. Every night in the summer, people come to watch the bat flight. And the peak season, 500,000 bats that are living in these houses, and it's become a tourist attraction. Urban bridges, like I said, those crevices under the bridges in Austin, Texas, the Congress Street Bridge has bats, 750,000 bats at the peak season. And you can see people lined along the bridge. People will get in canoes and kayaks to watch the bats fly every evening, and these clouds of bats are going out to feed on insects. So let's talk about bat diet. Worldwide, 70% of bats worldwide eat insects. The next large group are called nectar bats, fruit bats, and they're eating nectar and pollen of the flowers and then eating the ripe fruit. We don't in North America have the bats that eat vertebrates, but down in the tropics, there are bats that eat fish, eat frogs and lizards, birds, and small mammals. The fishing bats are really cool. They fly up to the tree next to a little pond, and when a minnow comes up and breaks the surface, it makes those ripples as though you had just thrown a pebble in, and those ripples go out, and the bat is echolocating to look for that ripple. And it flies down, it has huge hind feet, and it snags the fish because it's right next to the surface and goes to its favorite tree and eats it. In New Mexico, 26 of the bat species eat insects. So most of 90% of New Mexico's bats are insectivorous. However, there are 3 species that are nectar bats and eat the pollen. In this case, this is a century plant that the bat is approaching. Those big agaves put up a huge stalk and then put out these panicles that have flowers on them. and the bats come up and stick their tongue out and drink the nectar. And in the process, you can look over at the right picture and you can see all of that dusting of yellow pollen on the bat's head. And what these bats are important for is cross-pollinating these plants across hundreds of hectares. And in the tropics, there are even some plants that have co-evolved with bats. They open their flowers at night, at dark, as soon as it turns dark. They're light colored flowers, so the bats are better easily see the flowers, and they'll have a specific odor so that the bats can also smell them. But you can see that this bat on the right has a very large eye, and it's using vision a lot to find the flowers. And that when you look, if you've ever driven across the grasslands and you see the city lights, you can actually see the silhouettes of these huge agaves. For insectivorous bats, a nursing female will eat almost 70% of her body weight every summer evening. Lactation, rearing a pup is so energy expensive that she has to eat a lot. Now, this won't be in one bout of foraging. She'll go out at sunset, feed for a while, then either go to a night roost or go back and nurse her pup, depending upon how old the pup is. And then she may go out for a little snack before sunrise and come back. Many of the insects that bats find so delicious are insect pests, either on forests, on our gardens, our ornamentals, but more importantly on major crops: cotton, alfalfa, pistachio, pecans, wheat. The damage that these insects can do can be so critical to a farmer's success. And bats are foraging over these fields every night and gorging themselves on pest insects. One of the best examples of the benefits of insectivorous bats is Bracken Bat Cave in Texas. This is the entrance. It's a fairly large entrance. It's in the Edwards Plateau, so it's a big band of limestone. And this cave isn't particularly big. It's one sort of huge room. Every spring, 20 million female Brazilian free-tail bats migrate up from Mexico, and the cave walls are cream colored. These are covered with bats, and each bat has one pup. It's a maternity colony. Every night, when at sunset, the cloud of bats is so dense that they can pick it up on airport and weather Doppler radar. And in the area where these caves are, you can actually see this. All of a sudden, there's this spot on the Doppler radar that just expands out. And what they've done is they've shown these bats leave the caves, fly east, leave the Edwards Plateau, and go down over irrigated crops, alfalfa, cotton, wheat, and feed on tons of insects every night. So you could say bats are sort of a natural pesticide, or they're really good at organic bug control. So the impact of bats on insect pests are actually saving farmers and ranchers billions of dollars. There have been studies that show the economic value of bats, because bats had a negative, people perceived bats negatively. They were afraid of them. They didn't appreciate what they were doing because they do it at night, and we can't see them at night. So they weren't really appreciating all of this work that the bats are doing. And when bats are allowed to go out and feed every night, they have shown that ranchers and farmers don't have to spray so many chemicals on the crops, which can leave a residue, chemical residue, which can make us sick. So they're able to show that if ranchers are smart, they can reduce the amount of spraying because the bats are eating the insects. So bats are tremendous insect control. They're a major predator of nocturnal insects, and the nectar fruit bats are critical for pollination services, and when they come back to eat the fruit, for seed dispersal. Unfortunately, there are a number of threats to bat population. One is roost disturbance. We mentioned before that if you go into a cave and you find bats and they're disturbed too much, they will abandon the roost and probably go to a site that it does not have the appropriate temperature and humidity. Habitat loss is catastrophic across many, many organisms. This used to be a nice solid forest, and with clear cutting, that the thermal mass benefit of that, the number of insects were all lost. So this strip of forest has much greater edge for its mass, and the temperatures may not be as stable now. So habitat loss is critical for, is terrible for disturbing bats. Wind turbines. Wind energy seems like green energy, but you've probably heard of wind turbines killing raptors, eagles, hawks. They weren't quite aware that bats were dying because that's happening at night. And at first they thought, when they were finding dead bats below the turbines, they were thinking, oh, they were hit by the blades, but there were no broken bones. And it took them a while to discover that when the blades are turning really fast, it's too windy for bats to be flying. And so you don't see it then. But when the wind drops, these blades are spinning slowly, but they're creating a little vacuum behind the blades. And if a bat flies up into that, it collapses the bat's lungs. There's barotrauma. So it literally suffocates and drops to the ground. And they're trying to negotiate that at those lower speeds, when the blades are barely turning, that the energy turbine farms feather the blade, turn the blade into the wind so that they're not killing bats at that low speed. And this is the tree bat that has been decimated by wind farms, and it's the hoary bat. It's a beautiful bat. And most recently, white nose syndrome first appeared in New York State in 2007. And it's a fungus that attacks bats. It was first appeared as fuzzy fungus noses. It's unfortunately a cold-loving fungus that loves high humidity. And cold and high humidity in caves and mines are where bats hibernate. The fungus was irritating the bats and making them awaken, sort of like if you had athlete's foot and you just kept scratching it. But the more often that a bat wakes up, the more calories it burned on the fat reserves that it stored to make it through the winter undisturbed. In addition, what they've discovered is it's a keratin-eating fungus, and it actually eats the walls of the membranes. And this bat, of course, is dead, but this is how much the fungus is destroying the cells, which then totally destroys the physiological function of the wing. So where is white nose now? It's now it started here in New York. It's now covering 34 states and 7 Canadian provinces. And the spores of the fungus have been found in 4 more states, but there has yet to be mortality. White nose syndrome is the disease that the fungus causes. It's killed over 6.7 million bats, which yearly those bats would have eaten 4,000 tons of insects that are no longer being consumed. So you can start doing the economic impact. It can be catastrophic. The populations of insects won't be damped down by bat feeding on them, so there'll probably be more spraying. So how can we help? When we go into caves, we pick up mud on our clothes and especially our boots, the lugs of our boots. And if there's the fungal spores in that cave, we can take them from a cave that doesn't have the fungus to a cave that does. So what U.S. Fish and Wildlife has recommended is you go to their website. You never bring equipment from a state that does have the white nose disease, and within a state you always decon per their recommendations to protect from spreading the fungal spores from cave to cave. We should never enter maternity sites. Again, we talk about disturbance, but when you have pups on the ceiling, every mom's going to try and grab her pup and fly with it, and there are going to be collisions. Pups are going to fall on the floor, and the females may move the pups to a drier, colder cave, and they won't survive. In the fall, bats put on fat reserves to make it through the winter, and they go to cold, wet caves, like I said. This little bat has found a spot where condensation forms on its fur. So if it wakes up naturally in the night, it can lick its fur. In the winter, it can lick its fur and get a good drink of water. But if we go in and disturb bats and wake them up too often, they will burn through their fat reserves, just like the fungal spores are causing disturbance, and the bats will starve to death before the spring. But if we love our bats and appreciate our bats, again, these are faces from New Mexico. So when you look, unfortunately, when you look up into the sky and you see a bat flying, you don't really know how adorable the faces are. But now you guys have all become my goodwill ambassadors. When someone starts bad-mouthing bats, you can say, no, I've got some information for you now. All right, Beth, do you have any questions?
Thank you so much, Debbie. Yeah, there are a few questions that came in on the chat, and anybody can please keep typing the questions in, and I'll go through and ask as many as I can. Let me see. So I have to let you start your video if we're gonna
start my video.
Start that. Yeah, there you are.
There I am. All righty. Hello.
All right, so I hear, so we do have some questions for you, and then I hear you're maybe going to show us some.
Yeah, I don't know can I get bigger so I can see? I have Archie in my hand right now.
You're big for me. If anyone is
there you
having trouble seeing, if Debbie's video isn't as large as it can be, just try to look in the top right-hand corner or somewhere on your Zoom. You should see an option to change the view. And if you change it to speaker view, you should see Debbie and her little friend. Let's hear more about him or her.
So Archie is a big brown bat. So he's a beetle specialist. And he has an injured wing, and I have him on a game and fish permit so that I can take him to talks to be a goodwill ambassador. This will annoy him, but I'm going to open his wing so that you can see the hand. So let me get it back here. There's the thumb right there. And the fingers, there's his little finger. And he doesn't like it. Oh, yeah, I know. Oh, I didn't fold it right there. You see, I didn't fold it right. Sorry. And he's dropped a couple pellets on me. Yes, you're a good boy. Turn the detector on. So Archie's complaining to me. So this detector is bringing down the sound Archie's making. Oh, you just chewed me out, didn't you? So any questions?
All right, let's start with, do mother bats share any care of each other's babies when they're in the maternity roost?
That's a really good question. And the problem is, it's hard to know, because to go into a site and be able to observe that is disturbing. I have heard a hypothesis that if maybe a mom doesn't come back because it was eaten by a hawk or something, there might be, because the pup's going around looking for it, there might be some adopting, and it might be through kinship. So female bats are very loyal to their maternity site. They have their pup comes back the next year. So the pup, so mom and then granddaughter and great-granddaughter and great-great-granddaughter all every year come back to have their young. And so there's kinship sort of weaving through a maternity colony. But like I said, it's real hard to look at that. You could look at it genetically, but getting into the roost is so disturbing that it's going to take some technology to do that. Good question.
All right, thank you. This next one, I think actually a couple people may have asked this. You mentioned the fruit bats. Do they also use high frequency calls for echolocation? Someone said it might be, they thought it might be a waste of energy. Someone else said the nectar eating bats use it the same way that insectivores do. So.
Yep, that's a really good question, because the fruit bats have bigger eyes, and in the tropics they have even bigger eyes. They do vision a lot. They're looking for that flower. They're using the scent of the plant. So because they're using vision, they are not echolocating as much. And I study the lesser long-nosed bat in Arizona, and I can put out a bat detector at the base of an agave and watch with night vision. And if a solitary, one lesser long-nosed bat comes in and gets a drink, I won't record anything. It's like it was doing just vision. But you start getting echolocation calls if 2 or 3 come in, and that's probably more to avoid collisions. So they will talk to each other with conspecifics, and it will be up at 50 kilohertz, 50,000 cycles per second. But they don't echolocate all the time because their food is so stationary. You know, the echolocation of insectivorous bats is to find a very small prey item that's moving. The agaves don't tend to move that much, and so that is a good question, and they hit exactly on it. Echolocation does take energy. Now, what's interesting is bats echolocate in synchrony with the wing flaps, so that inhalation and exhalation is aided by the wings and the chest opening and closing. So even insectivorous bats that have to echolocate to find prey items, they're doing it efficiently. Next.
All right. Someone wanted to know, why are hoary bats more susceptible to death or injury from the wind turbines?
Excellent, excellent. And there is a reason. It seems to be the tree bats. So they find a lot of red bats, which are use sycamore and cottonwood trees, and they're red bat, they're beautiful red fur. And when they hang next to a dead leaf in a sycamore, you can't tell them apart. They just have that beautiful coloration. And it's probably because those towers with the turbines going around look a lot like a tree, a big tree. And there may be mating that's going on in the fall, and they're kind of going into that big tree-like structure. But it does seem to be a lot of tree bats that are killed by the wind turbines, but not exclusively. They used to hypothesize maybe insects might get drawn into those blades when they're going very slowly. So there might be, you know, a pocket of insects that the bats are being attracted by, but they're still working it out. There are a number of bat biologists that have been working with the wind turbine energy to try and tease some of this information apart. But that's a really good question, because it does seem to be unequal in the species that are killed. They also, wind farms tend to be along ridges. And it may be also that the tree bats are using those ridges as a migratory avenue, because it seems to be seasonal, and might be when bats are using landscapes to migrate from summer to winter, or vice versa.
Great, thank you. Well, the poor hoary bats, though.
Oh, they're beautiful.
So we do have a lot more questions for you, Debbie, but I did want to kind of respect everyone's time. It is right around 8 o'clock. So if anyone needs to go, this is being recorded and we'll have it available up on our website. And I also want to just give a quick plug in case anybody has to go. Oh dear, I just got very distracted by that adorable face.
This is Rosie. This is Rosie, a pallid bat. They're called pallid bats because they have such pale colored fur. Big ears because she does listen for prey items. She may hang up and listen for beetles in the leaf litter. They will, pallid bats also, she's a little agitated. Pallid bats will also land on the ground and take scorpions and centipedes. Because the wing shape is so broad, pallid bats are one of the few that can lift the weight of a prey item and take off. If a bat has very long, narrow wings, it's like a lot like a jet, and it falls out of the air if it goes too slow. And if you look at Rosie's wing, that's very broad. And so she can actually lift grasshopper, beetle off the ground and take off with it. That's a good girl.
It looks like she has larger eyes, like you were talking about.
She does have a lot larger eyes, and so she may do a lot with vision too at night.
Awesome. Okay. Well, I'll jump into more questions, and I'll try to keep up. There's a lot coming in on the chat, so let's see.
I'm here until. See, it's an hour earlier here, so
that's right.
It's only 7 o'clock here. The night is young.
So, real quick, do you have a favorite bat?
You know, I hear that a lot, and
oh, that's a little low. If you can bring them just up a little higher. There we go. Oh,
she doesn't
snacks.
Archie Elite. My favorite bat is the bat I'm holding at my hand at the time.
Good answer.
They're always so cute.
In general question, why do bats hang upside down?
Oh, these questions are awesome. Because there's a reason for all of it. One of the reasons is it allows bats to get up above predators. So if they're not walking around on the ground, they're not going to be preyed upon. So they're hanging up and hanging by their hind feet. So to fly, you can't have really large, robust bones and still be a small animal. It's sort of a balance of size and the ability to fly. And so the bones get finer. And bat bones, New Mexico bat bones, the finger bones are just real. They look like a little piece of straw. They're so fine. And if you hang by your hind feet in a cave and open your wings and drop into flight, that's aerodynamic. You put no energy into flapping, you just drop into flight. The big bats, the big free-tailed bats like Brazilian freetail, pocketed freetail, big freetail, and the Western Mastiff have long, narrow wings like a jet or a swift, and they can fly really fast, and the big freetails can go 60 miles a night foraging. The Mexican freetails, Brazilian freetails are probably going 30, 40 miles from where they're roosting to feed. So you have to have narrow wings. You have to be like a jet. but it's just physics. If you have narrow, long wings, the slower you fly, you'll fall out of the air. And so wing shape is really important to where you forage. If the big-eared bats, like the one I showed you that with the moths that had hearing, those big ears, they tend to have very broad wings, a little shorter and very broad, and they can actually almost hover. And so they are able to forage in amongst vegetation and pluck a moth off a leaf. And there's no way the free-tailed bats could ever do that. And so this is kind of how bats have moved into these niches. They're bats that feed over water. The Yuma myotis that lives in New Mexico. The Yuma myotis has big feet, and it forages right over the surface of the water. And it will snag insects either caught on the surface tension of the water or emerging, mosquitoes and mayflies and things. So that's where they forage, and that's what they feed on. And so the wing shape, the echolocation type, it all is driven by this niche division that's why there's so many bats. The diversity is speaking to different techniques to make a living.
Thank you. Okay, we had a couple people ask.
Not wanting to be eaten and dropping it efficiently into flight. Okay, Archie, you want a meal one?
Awesome. Oh, he's hungry. That is
He is hungry.
Little mealworm snacks. A couple of people are asking specifically about Carlsbad. We had some, let's see, what types of bats and how many are there?
What they're probably thinking is the bat flight, and that is Brazilian freetails, Mexican freetails. People call it two different things. That's Tiderata brasiliensis, and that's a maternity colony. And the population fluctuates from, it builds in the spring because that species of bat has spent the winter in Mexico, doesn't hibernate, it goes south to Mexico where it can eat every night. And it migrates back up to Carlsbad, and each mom has a pup. And so the population is varying. And I haven't heard lately, it's probably 800, 900. They used to think it was a lot bigger, and then someone did a model of the throat of the cave, and they said that, yeah, it was clouds of bats once, but people had overestimated the population. So it probably gets up into, I haven't asked lately, it's probably a couple thousand, but you need to talk to somebody who's talked to the park more recently. Now there are a number of other species on the park, and Diana Northup and I have been swabbing the bats on the park, and we go out and mist net at some of the pools on the park property, and we go back to the left-hand tunnel. So we have netted and swabbed cave myotis, fringed myotis, Western Canyon bats, hoary bats, Brazilian freetail. I've lost track. But they probably have on the park, they probably have about 15 different species. Again, there's all those niches. There's canyons, there's cliffs, there's caves, there's trees. And so they have lots of bats at Carlsbad, but the ones that make the bat flight are the Brazilian freetails.
Great, thank you. Someone asked, they said they're an avid hiker around here, and what would they do to protect bats if they found a rookery?
So they're talking about like a cave colony, a bat colony.
Yeah, or I think around here might be more common in the, in cracks in the canyon walls.
Yes, yes. So places where bats could make be roosting in the daytime.
Yeah, and if they found them there, anything they can do to make sure that they're going to be okay.
Unfortunately, probably it's not telling all your friends so they go out to look at it.
Right, leaving them alone. That's what I thought too.
Yeah, it's really leaving them alone, not drawing attention to them. If it's on Forest Service land or Park Service land, you might tell the agency biologist so that they're aware of it. If there's going to be some land alteration or a power line put in, it would be helpful if they knew that the colony there was a bat roost there to protect it. But if it's up in a 10 feet up, go back at sunset and watch the bat flight in the summer. Because if you're not near the entrance, the bats, if you're away from the entrance, what you can do is highlight them against the western sky. And you can see them a little later that way, because as they come out, they'll, they can be, I've done this with a number of caves where you can almost count the colony size if you can get them backlit.
So enjoy them and
yes, enjoy them and protect them
from a distance.
From a distance.
Kind of a similar question though about bats in houses. Best course of action.
It depends upon where you live. In New Mexico, I would highly recommend that you get a hold of Justin Stevenson. He has a bat. He has a company that takes care of orphaned animals, but he also is a bat biologist that will properly exclude bats from a building. You don't want dead bats, smelly bats. You want to do it safely. There are different techniques that Justin uses. Sometimes you put a flap of fabric so the bat can crawl out and get underneath the fabric, but it can't come home. But it's really critical that none of the exclusions be done in the period that moms have pups, because if you don't know who's using your attic or whatever, or a crawl space, you don't want to kill all those babies. So you want to be safe about it. And I would, highly recommend get a hold of Justin and Stevenson, and he will know how to protect the bats, help you exclude them, but protect them. And he's just outside of Albuquerque, but he goes all over the state.
Yes, we've had Justin.
He comes, what really cool thing Justin has is he builds, as new bridges are built, they don't have those beautiful crevices. They're doing these flat slab concrete bridges. So they're not bat friendly. There's no place for the bats to roost. And Justin has designed these bat houses that can be retrofitted underneath the bridge deck, and the bats can live there. They just don't have the same crevices, just new crevices. And he's done those in Tucson bridges. They've been rebuilding bridges in Tucson, and he comes over and mounts his bat houses, and everybody's happy.
Yes, we've had Justin at the Nature Center before, and
good.
I refer people to him a lot. I'll actually go ahead and put his
contact.
Yeah, the website for RD Wildlife is in the chat now.
Excellent, excellent.
Oh, and now I need to scroll back up to the last. Okay, so just a confirmation. Someone wanted to know what the bat was with the big ears like bananas, and are they in New Mexico?
Yeah, those are pallid bats, Pallid. The scientific name is Antrozous pallidus, and they are in New Mexico, and they're wonderful bats. And they're kind of interesting because they have a social call that we can hear. And if you're near a colony, if you're near a roost where they're pallid bats, when they're foraging at night and coming back and in and out of the roost site, they do these little sing-songy directives. And it's within our hearing. So sometimes you might hear it in the air and wonder, it sounds like a bird, but it's nighttime. But they're really wonderful bats, wonderful, wonderful bats.
Great, thank you. We actually have a Department of Health employee on the presentation listening in, and he wanted to ask if you would mention that it's not safe to pick up any bats or sick or injured bats.
Absolutely. Never ever handle a bat. If children should be warned, the bats that I have, I'm a bat biologist. But if I'm ever out working with wild bats, I'm always totally gloved. Children should be warned told to love bats, watch them fly. But because they're small, children tend to want to pick them up. And they should never, ever pick up a bat. You get an adult, if you have pets, you should make sure that adult moves the bat away from pets and children, and that they call the local health department, or I don't know, it would vary from city to city, but it might be animal control, because there are two reasons that bats end up on the ground. One is they've been injured, they have a broken wing, or they're down on the ground because they're sick. And rabies is a fatal disease, and people should enjoy bats up there and never handle bats, because rabies is nothing to mess around with. When I'm working with bat vets and wildlife biologists, always get pre-exposure immunizations so that if we get bitten, we get boosters and we don't get rabies. But no one should ever, I mean, if you see a bat on the ground, get heavy gloves and pick them up and move them away from kids and children, and contact an agency that would know how to assess whether the bat, there's some rehab centers that are able to do that too. Justin would probably be able to do that, would come out and assess if it has an injured wing. You know, Justin could take care of it till it can be released, but he would always put it in quarantine. When a bat comes into a rehab place, you assume it could be rabid. Now, that doesn't mean that all bats are rabid, but if a bat is in town and acting odd, then you should assume that. If it's out flying and doing its business, you know, that's what a bat should be doing. So, you know, you assume that any mammal that is not acting normal could be rabid. So if a coyote wants to walk up to you, or a bobcat, or a skunk, assume it's rabid.
Okay, thank you. How did Archie come into your care?
Archie's 17 years old. He wants to drive now. He wants the car keys because he's a teenager. Yes. He had an injured wing. It has healed, but he never flew well enough to be released. I have rehabbed bats and they've done fine. And I take them out to maybe a roost where there are others of their kind, so they kind of loop, or either where they were the area they were brought in from, and they can be released back into nature. I would really rather release a bat back to where it's happiest. I have Archie and Rosie because they would be dead in a day or two, starving to death if I put them out in the wild. So they're goodwill ambassadors. There he's echolocating, wiggling his nose, wiggling his nose. And see, it's above our hearing. I wasn't lying. So he's probably about 30, 40 kilohertz.
And what's the device you're using there?
This is an Anabat bat detector. And the microphone is sensitive to high frequency sound. So the sound comes in and the physics of Fourier transfer, the physics of this translates it down to what we can hear, but it also processes the call and stores it on an SD card in a picture that shows where the frequency starts, where it ends, the shape of the bat call. And bat echolocation is fairly species specific. So I can put this detector out on the landscape overnight, and every time a bat goes by, it's recorded and a date and time stamp put on. I can take it home and I can look and go, oh, 10 o'clock, a big brown flew by. Oh, 11 o'clock, a little Western Canyon bat flew by. So this is a really, really helpful tool in doing activity levels and species diversity. You have to be careful because a single bat flying past this 10 times, or you could assume it's 10 different bats, but it was only one. So it only does activity levels, not a population. Yeah, he's trying to open his wings. Yes, you're trying to open your wings. Good boy. You're a good boy.
All right, one more about bats in buildings. And this might be another question for Justin at RD Wildlife, but how would you properly remove roosts in old buildings, like ones that are ready to be demolished?
Oh, those are tricky. Yes. It's difficult because, you know, they need to be taken down for whatever reason. And if it's a barn, it really is a Justin question, because you kind of need to know the landscape that the building is in. Is there a colony of the same species nearby that, but what I would say, and Justin might say this too, is it's not a natural roost. And if you have to take it down, you take it down in the dead of winter when bats aren't using it, unless it's, you know, used as a hibernaculum. But if the bats have moved away for the season, if you take it down, when they come back in the spring, they'll fly around and then they'll have to go find another spot. But it isn't a natural roost. And we do understand that these things happen, but you should never tear it down when it's occupied. I've had to pick up baby bats because someone tore down a building and it was a maternity colony and a lot of the babies died. So timing is important, even if you're going to exclude bats from your attic and seal up the crevices. You should always do it off season of the bat activity.
Okay, are there any bats that aren't nocturnal?
I'm starting, well, when you go to Australia and see the flying fox, those bats that have like a 6-foot wingspan in Sydney and stuff, they're big fruit bats. They hang out in trees and appear to be, I mean, they're sleeping, but if they get hot, they'll open their wings and fan them. And, but to go out and feed, I have seen in the fall, I have seen Western Canyon bats feeding at 2 in the afternoon in the shade of a cliff. And I've wondered, I didn't catch them, but I've wondered if they're putting on fat reserves, they're trying to catch those little insects that are in the shade. It's kind of dark in the shade. There is always a risk that a hawk or some other bird will snag them. So it's a trade-off. It's whether or not you want to take that risk. But I have seen bats out in canyons on the shady side, but usually in the fall, because summers it's a little too hot.
Someone asked to explain again why the insectivorous bats would have large eyes.
Well, most insectivorous bats have small eyes like Archie, but the insectivorous bats do have large eyes. It may be helping them forage. Like the pallid bats will hang up and watch beetles go by and stuff and jump on them. And it may be that they're using vision rather than just echolocation. But the bigger eyes tend to imply that they're using vision maybe a bit more to forage than like Archie. You almost can't even find his eyes, but they work pretty good, don't they, Archie? Yes, they do.
All right, what about the fastest bat?
They have said the fastest bat is the Brazilian free-tailed bat. There was actually an article fairly recently that said it was the fastest mammal and quoted a speed that I don't quite believe unless it had a tailwind. But yes, there was an article written recently that said that the Brazilian or Mexican freetails are supposed to be the fastest bats.
Okay, thank you. Are all bats colony dwellers, or are there some that are solitary?
No, a good question, because it's both. The Tadarida, the Brazilian freetails, make the largest congregations of bats in the US. Millions, in the millions. And usually in Texas caves, or where they're the best known. But the Little Western Canyon bat, colony of 5, is a big colony. Then you get big browns, 30 to 50, 100. And then you have the tree bats, and the tree bats are solitary because they hang out as individuals in the trees where they could be preyed upon. They don't make a colony because that would draw attention up to a lot of bats. So the hoary bat, female hoary bat, will be hanging alone with only her pups. The males will be hanging alone in the trees. The red bat is in New Mexico. The yellow bat is in New Mexico, and the silver-haired. And those tend to be solitary, with only the males are solitary and the females would hang with a pup. But the range is from millions to individuals and everything in between. The bat picture that I showed of, it was a nectar pollen bat that had all the pollen on its face. They make big colonies. And I study a colony on Fort Huachuca in southeastern Arizona, in Sierra Vista, just outside of Sierra Vista. And the peak number in the season is usually around 16,000. And cave myotis will make big colonies of 10,000. So it varies, and it tends to be sort of species specific.
There are a couple questions about bat boxes, mostly about insulating them. I know we've gotten a few questions at the Nature Center about how do I get bats to move into my bat box? And
I know it really is you need to be near a foraging area. So you need to have bats in the area. And so if you're near a pond, if you're in a forest, you need to hang it. So in the Southwest, you need to hang it so that you're not baking your bats. So they need the bat house needs to be up high enough so the bats can drop into flight and that nothing can climb up to it. So a lot of people will attach it to a tree and not realize that squirrels can get up in there and eat babies, or lizards, or blue jays. So they like to be away from any area where a predator could climb up, and the bat needs to drop into flight. Here in Tucson, you always the couple people that I've heard are successful have put foam core on the sides and then painted it so that it doesn't degrade immediately. And then probably up high on the eastern side of a house. So it gets morning sun, but it does not get the heat of the afternoon. Now, that said, people will complain because bats are in the crevices where a big brown bat or a little Western Canyon bat will be pooping on someone's patio, and I come out and there's a gap, there's the house and then a wood fascia, and there's a little crevice. And the reason that they like to roost like that is it ameliorates those huge temperature extremes. It's a nice heat trap. So they'll choose your patio. And if you look at how, a bat might choose where near the house the bat might choose, then that's where you want to put a bat house, somewhere similar to those temperatures. But for anyone listening to this, they may be listening from Pinon juniper, and that's going to be different requirements. But if you're near good foraging, I'd give it a try. It's a great conversation piece if nobody moves in.
Okay, thank you. I think there's just a handful more. They just kept coming. Any other notes about cultural interpretations here in New Mexico?
I'm not as familiar with Native American art in New Mexico. I'm mainly familiar with the Mimbres, but I'm quite sure that I asked every culture, every Native American culture is going to have a different name for bat, different word for bat, and I would believe, and this is kind of me just talking, but I would believe that Native Americans are closer to nature and the earth. And I would bet there are probably legends. I've heard of a couple, but oral legends about bats and maybe mystical abilities of bats because they're nocturnal. They tend to be a little bit different than all the other animals they see. And so it would be very interesting for someone to go out and do oral histories of the different Native Americans, to look at their legends before they're lost, because I think they're going to be much more positive than the European legends.
Okay, someone did just chime in and say that they think there are very few bats in petroglyphs in New Mexico.
I could believe that. Yeah, because I've looked throughout the Southwest, and I would say I've never seen a bat, but the Mimbres have them in their pottery. But I think a lot of them have legends. They may not be doing it on their art, but I bet they almost all have bats within their tails.
Okay, and then when we're out at night and we hear bats chiming, flying above us, what are those calls?
So they're hearing probably a chirp, chirp, chirp. It's within their hearing. Is that what they're saying?
Yeah, I think if they can hear it, for sure.
Yes, those are way cool bats. The ones that, okay, there's probably 5 species that will do that. 4 of them are in New Mexico. So the Western Mastiff, the largest bat in North America, echolocates at about 10 to 12 kilohertz. Well, that's well within our hearing. And I hear them in Tucson. If you're listening and you hear a chirp, 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 and you hear the chirp moving, and it can be pretty high. I mean, you can hear it, but it's not 10 feet above your head. That's going to be either a Western Mastiff or a big freetail bat. It's Eumops parotus or Nyctinomops macrotus. And they both echolocate below 20 kilohertz. and we can hear them. Then there's the spotted bat and the Allen's lappet-browed bat. And they are also very low frequency, but they're not, you know, sort of chirp, chirp, chirp. It's more like a click, 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 and you're hearing it. And you're not sure what it is, but those are bat calls. Those bats are echolocating below 20 kilohertz. So New Mexico has a handful of them that are below 20 kilohertz. And so good for you. You've heard either the freetails or the Allen's lappet-browed and the spotted have very big ears. The last picture on my program was an Allen's lappet-browed. So they're sort of big ears, so they can catch probably those moths that can hear. But their echoes are probably fairly faint, so you'd have to be right near them. I've heard both species, but it's not like that loud chirp that you get with the freetails.
I know we definitely must have a couple different ones in White Rock Canyon because it's just down the hill from Los Alamos, and we hear a lot of them right along the canyon edge every night.
It's the chirping,
the chirping, and also some a lot smaller ones that you can't hear. So
yeah. Oh no, the bigger freetails, they love canyons. They are probably roosting in crevices high so they can drop into flight. They really like canyons, and I would bet that you've got the big freetails up there, no problem. I know Justin knows where there's some big freetail colonies. So.
And there used to, actually someone mentioned that there used to be a large colony in Bandelier National Monument.
I've heard that.
They used to actually have bat flights there as well. Like people would come, it was a tourist attraction.
So what happened?
I don't know. They moved out of this. I think someone once tried to point it out to me exactly which crevice, and it was, there were no bats there at the time. So.
No, that's too bad, because I'd heard about Bandelier. Was never able to get up there, but I'd heard they had a bat colony that was worth watching the bat flight. Yes,
I have heard that too. All right, I think that's it. Oh, you know what? Sorry, one that I skipped. Do any of the bats have summer, winter fur coats? Do they change, or do they just migrate?
They molt. Bats molt. So it isn't like they suddenly look naked, but you will see kind of a thinning. I think it's sort of a gradual thing where they molt seasonally, but you don't get the heavy coat and the light coat that you get with cattle or if that's what they're asking. No, they don't have a seasonal heavy coat and a light coat, but they do molt seasonally.
They're not always.
They do it in the summer, so it must be gets thin enough so they like to do it when it's warm.
So it's not like they're always shedding, but maybe kind of like our pets, they might shed more as it's hot. Okay.
Yep. And putting in, new fur. I don't know that I didn't touch on this, but bats are fastidious groomers. When people think bats are dirty, that couldn't be further from the truth. They're constantly grooming. They use their hind foot as a little comb, so they're combing their fur all the time, and then they lick their toes, and then they comb their fur, because their fur and their wings, they'll also open their wings and lick their wings, and so they're always taking care of their fur and their wings. They're just fastidious groomers, and people don't really realize that.
Okay, I think, let me take one more look at the chat. I think that's the end of the questions. So for those of you that are still with us,
thank you. It was fun.
Thank you. Thank you so much for tuning in.
This is the first Zoom meeting, and it's a little depressing because I just have my two bats with me. I always like feeding off the energy of the audience, so it's kind of a letdown, but
Well, I can tell you that there's a lot of people chiming in on the chat, just saying thank you so much, and this was just a wonderful presentation. Just lots and lots of thanks there, and yeah,
they're probably saying give Archie and Rosie extra mealworms tonight.
Yes, they deserve it for sure. And yeah, thank you for letting us see them and meet them. I hope they keep being ambassadors for years and years to come. You said Archie's 17. How old do you think?
Rosie's tricky because she came to me as an adult. She was found by someone in Carlsbad, New Mexico, and she had a badly broken wing. And she went to a vet that I know in Carlsbad, and they were able to. It was a compound fracture. They were able to heal it, but not enough so she could ever fly. And there was some real damage. And so she had to become an educational outreach outreach bat. And so I took her because pallets with the big eyes and the big ears and the little pig nose, they're a lot of fun to show audiences. So she's still taming down. So, and she came as an adult. She had sharp teeth, and tooth wear can kind of tell you if it's a older animal or a younger animal. But you can tell after a female has reared a pup, you can tell that the nipple has been used. So a bat that's never had a pup, you almost cannot even find where the nipple is. But once it's nursed, you can tell that it's an adult that has had at least one pup, and she had nursed. So she was probably 3 years old, and I've had her 2, so she could be 5, but it's harder when they come in as an adult.
Well, she's sure living the good life now.
Yes, she is.
All right. Well, again, everybody, look for an email from us with a quick survey. And yeah, thank you so much again, Debbie, for sharing your incredible presentation and just so much information. I'm really excited to know all of that now.
Well, the problem is I could talk all day about bats, so you've constrained me to an hour.
That's great. It's just great to see your enthusiasm for them, and they're obviously very special little critters.
Yep.
If anybody wants to join us again this Friday, we have an astronomy presentation about searching for life on Mars. So look at our website for that and lots more stuff coming up. And I'll go ahead and just say goodbye to everybody here. And
I don't think Mars has any bats. That's the downside. That's why I'm not volunteering to go to Mars.
No bat life on Mars.
No bat life.
No. Not even in the caves and the sinkholes that they're finding there.
Yeah.
That's some interesting stuff. Yeah. All right. We'll say goodnight to everybody for now.
Thanks, Beth.
Yep. Thanks everybody for coming. Thank you again, Debbie. We'll see you again soon.
Okay. Bye-bye.
Bye.